Bats are incredibly difficult to study. They're small, they're fast, they are nocturnal, so they're active at night. They're smart. They learn if we catch them. They learn to avoid the places where we catch them. They can fit in tiny little spaces where it's hard for us to even know that they're there. How can we find them when they're in a space that something that's the size of a shrew can fit in? They're tiny.
There's a great deal of diversity in the bats that we have here in North America. While they may look a lot alike if you just see it fluttering across the sky, if you actually have them in hand and actually get to see them side by side, you'll see there's a huge number of differences among them. Some are really small and tiny, some are much larger, some have huge ears, some have smaller ears. Their coloration can be very plain, brown, to really dramatic orange or black and white with spots. There are reasons for all these differences among the species: the size of their ears, the shape of their wings. It determines how they fly, what their flight style is, which determines what type of food that they go after, what types of insects they go after, where they actually forage for these insects, and how well they maneuver around the environment with their flight.
There are bats in almost every park in the country, except in the high Arctic in Alaska. And that's amazing. At least one species, and in many places we have a dozen or even 24 bat species in some of the parks in the desert Southwest. It's quite remarkable. So the National Park System is a place for doing bat conservation and for protecting these special animals.
So we have bats that roost in a number of different habitats at Mount Rainier National Park. People often think of bats as being cave specialists, and in some places bats do congregate in caves, but here one of the really important habitats that we have are snags. So we have, in some places in this park, forests that are 1,000 years old, and some of the structure that's really critical for bats are things like these old snags. Some of the other habitats that we know that they use are talus fields and also cliffs.
In order to understand more about them, we have to go to where they are. We have a variety of tools to use to study them. Some are more hands-on and some are hands-off. Our hands-off tools could consist of acoustic monitoring, where we set up equipment that can pick up their ultrasonic echolocation.
You can set up an acoustic detector that records the vocalizations that they're making. We need specialized computer equipment for that. We can listen to see who flies by. So this is a real-time call of a big brown bat as it is approaching and then flying away from a microphone.
The hands-on tools that we have are setting up mist nets.
We set up a net that has a very fine mesh that the bats can fly into. When we catch them, we can identify the species, we can identify the age, we can identify the sex. We can also determine how healthy an animal is. We can determine if the bat's a female, if she's pregnant, and get more refined information about the animals that are using a habitat.
Bats can live in a variety of habitats, but caves make ideal places for them to live. They provide cover from predators, as well as fairly stable temperatures. So in our network, we have 8 or 9 species of bats that use caves at least some time of the year, including the impressive-looking Raffenest big-eared bat. We also have endangered species like the Indiana bat and the gray bat. So we've figured out a variety of scientific approaches or methods in order to monitor the bats on our parks. During the summer when bats are active, we use a more high-tech approach to count them. It involves the use of night vision video cameras, thermal infrared cameras, night vision goggles. So the cave behind me is an excellent example of a cave that's used by bats during the summer. Towards dusk, they'll fly out to go eat insects. They might return several times during the night. We use a night vision goggle and a clicker to count the bats as they exit and sometimes enter the cave. Back at the office, we download the video files, analyze them, and use them in our data models to get the most accurate count that we can. In recent years, bats in our network that hibernate in caves have been devastated by a serious, deadly disease called white-nose syndrome. It has devastated bat populations and brought many species to the brink of extinction.
White-nose syndrome is caused by a fungal pathogen. It was identified on the East Coast. Scientists have been monitoring its range expansion west since it was first detected in New York State. It's devastated bat populations in a number of places.
So in 2016, scientists were really surprised when white-nose syndrome actually showed up in Washington state. It had made a big jump across the country from some of the eastern states over to Washington.
So the white-nose syndrome detections from Washington were just about 30 miles from Mount Rainier National Park. My background as a disease ecologist poised me to take the lead for the national parks in Washington on white-nose syndrome surveillance and monitoring so that we could determine the extent of the disease occurrence and we could understand whether it's even a threat to our bats.
So we use the ultraviolet light to look for fungal spores for white-nose. They'll show up as a bright orange. Here we're just seeing some pollen on the wings.
Well, if you're interested in white-nose syndrome, you have to look at what's going on in the winter. Pseudogymnastis destructans is a cold-loving fungus that can only grow on the bats when the bats lower their temperature during torpor. So if you want to know what's happening with white-nose syndrome, that's when you got to look. We're going in and we're going to check the ceilings and the walls, every nook and cranny of that cave, and document how many bats, what species of bats. One of the questions we had was, with our caves being very different from caves in the east, these are lava tubes, these aren't limestone caves, are the conditions even right for white-nose syndrome to grow here? And at each bat we're going to take a temperature, we're going to take a humidity reading, and unfortunately we learned, yeah, white-nose syndrome, it'll grow just fine here. In the east, it's more typical that they'll find hundreds of bats on the ceiling and they're all clustered together. Out here in the west, it's rare to find very large hibernacula. Out here, most of our caves, it's 2 to 7 bats in a cave. The difference is we have thousands of caves out here. So if you start doing the math, we still have large numbers of bats like they do in the east. They're just not all in one cave.
Plants and animals are part of not just our natural heritage, but our cultural heritage. When any one of those species is at risk because of an impact, that's something that we want to pay attention to, because the loss of that species means not just the loss of our natural heritage, it means the loss of our cultural heritage. Part of the Park Service mission is to preserve both of those things. And so when we see bats being particularly vulnerable to a disease like white-nose syndrome, we respond by increasing our monitoring and increasing our disease surveillance.
Bats are everywhere, both inside and outside of our parks. And our national parks protect some very important and unique habitats. So we in the National Park Service want to do our part to protect bats and give them a fighting chance for the future.